Hi friends, here is a simple problem based on continuity of functions. We are given this function f of x equal to half x minus 1. This is defined on this interval 0 to pi closed interval, right? And we have greatest tan of greatest integer function of f of x and 1 by f of x, f inverse x, etc. etc. Okay, now which of these functions are continuous or not continuous is what we have to figure out. Firstly, there is a greatest integer function of f of x. Right. F of x is trending between is between 0 and pi. So what is the minimum value of f of x? First of all, this is a linear one, right? Minimum value is half of 0 minus 1, which is minus 1. And what is the maximum value? Half of pi minus 1. Half of pi is some 3.1 by 2. So roughly 1.6 minus 1 or something. It is roughly some 0.5, 0.6. Roughly some 0.5, 0.6. Okay, now greatest integer function of x. So greatest integer function of f of x can be either minus 1 or 0 because when it is pi by 2 minus 1, right? 1.5 or 1.6 minus 1 is 0.6 or 0.5. So greatest integer function of x, um, this half of x minus 1 is standing between 0 and, sorry, minus 1 and 0.6, right? This is minus 1 and 0.6. Right, so greatest integer function of x can be either minus 1 or can be 0 because this is only about integers. Right, so now tan of greatest integer function of f of x. What does that mean? Either it can be tan of minus 1 or tan of 0. Right, either it can be tan of minus 1 or it can be tan of 0. Right, when x is less than 2, we are talking about half of x minus 1. When x is less than 2, obviously greatest integer of function of x, right? This is less than, when x is less than 2, this is less than 0. So it should be minus 1 or otherwise it is 0. Greatest integer function of f of x. That's what we have figured out. Either it would be minus 1 or 0. So before 2, it would be minus 1, right? Half of x would be lesser than 1. So, and a number lesser than 1, minus 1 would be negative. So that should be minus 1. So tan of greatest integer function of f of x is either tan minus 1 or tan 0, right? Depending on whether x is lesser than 2 or greater than 2, right? Now clearly one side before 2 there is, this number is something else, after 2 this number is something else. So limit is not matching. Limit, so before 2 there's a discontinuity here, right? One side it is tan of minus 1 and another side is it is tan 0. So both sides that is not matching. So this function is clearly not continuous. If it is continuous, what does that mean? Limit at any point, limit when x tends to 2 should be equal to f of 2. Right, limit of the function when we approach from the left side of 2 or right side of the 2, at the same time f of 2 should be equal to the same number. Right, here in this case left side number is not equal to right side, so tan of f of x is not continuous clearly. What does that mean? The option D is wrong and option A is wrong because here in both cases they are mentioned continuous. Option C is also wrong. Let us verify about option B. 1 by f of x, is it discontinuous or not? 1 by f of x. Half of f of x is half of x minus 1. That is nothing but x minus 1 by 2. 1 by f of x is what? X minus 2 by 2. 1 by f of x is reciprocal of this, that is 2 by x minus 2. Obviously, here when x equal to 2, this function is not defined, right? So there is a break at x equal to 2, right? 1 by x graph will look something like this, right? And 1 by x minus 2 will look like the same graph shifted 2 units towards right. Right, so 2 by x or 1 by x, this is 2 times of this 1 by x, so it will look something like this. So there will be a vertical asymptote here when x equal to 2, right? The graph will look something like this. At this point 2, there will be a vertical asymptote. right? One side it will be positive, one side it should be negative, negative infinity, positive infinity. So clearly there is a break here. It is not continuous. When x is between x is at 2. Now here the question is about between 0 and pi. 0 and pi, 2 obviously is there between 0 and pi because 0 and 3.1. So 2 is there in the between. So 1 by f of x is definitely discontinuous, right? Because at 2 it is breaking. So the correct answer is actually B. You can even verify about f inverse x, but that is not needed, right? So f of x is a linear function. F inverse x is also a linear function. F inverse x is continuous, but tan of greatest integer function of f of x is discontinuous. So that's why we have ignored C part, and the correct answer is B. Right, guys? Hope you like this very basic problem. Thank you.